Okay, so we learned about the factor theorem, the remainder theorem yesterday. So if we were dividing a polynomial by x minus a, we could get the remainder in a faster way by substituting a into the polynomial, rather than doing log division or synthetic division. So the factor theorem is an extension of that. Basically, you want to figure out what's the remainder if we're dividing by something that is a factor. It does go in equally. Okay, so we're going to start again with a number example. We've got 18 there. It says what happens when we divide a number by one of its factors. Hopefully you know, but let's find out. So what are all the positive factors of 18? List every single number that divides evenly into 18, including 1. So just list them out. So obviously 1 goes in. Check 2, it's an even number. 2 goes in. Check 3. 3 times 6 is 18. There's nothing between 3 and 6. So the next is 6, and then 9, and then 18. Okay. Now, technically, we could include, no, I'm going to leave that out. Well, we could divide by a negative and get a negative answer, but we're going to leave that for the next part here. So those are factors of 18. When we divide 18 by one of its factors using long division, you don't really have to use long division, but let's say we do it here. Actually, yeah, so you should know. But in the long division, when you do that, remember that number there is the remainder. Okay? So the remainder is 0. So that's what makes a number a factor. The remainder is 0. Okay? We just haven't used that word remainder for a long time since you're in elementary school. But essentially, that's what it is. So what about polynomials? Well, the same thing is going to apply, except now we're not dealing with just numbers. So it says write the equation of p of x using its x-intercepts. P of x is drawn for you here, okay? And so you can see the x-intercepts. And so you can use your work from earlier in this chapter to come up with an equation of that. Okay, so here, now we don't know what, I'm going to put a for right now, and then put my factors. Okay, but we have been given the equation. And take a look, the leading coefficient is 1. If I have an a out front and these are all x's, then a must be 1. Okay, so we don't need to show anything. But if we weren't given the equation in simplified form there, we would actually have to take, say, for example, the y-intercept, substitute it in, and solve for a. Okay, to make sure we have the exact equation. In this case, we were given it. Okay, that equation that we found is in factored form. Oh, sure. Oh. In your pocket. So what are all the factors of this? Those are the factors. We're just asked for the factors of the polynomial. That's what they are. We really don't know how to factor something that's degree 3 and 4 terms. Sometimes back in Math 10, you may have factored by grouping, but I can't group those and factor them. So that's sort of why we're learning about this factor theorem, so that hopefully we can end up using synthetic division and then breaking it down into something smaller that we can factor. Okay, so determine, now we're still on the same process. We're now looking at this polynomial function p of x. And hopefully that goes away. And I want you to use synthetic division to divide by one of one of its factors. You decide which one. I'm going to use x plus 2. So this is a good review from yesterday. Move that down a little bit here. 1, -2, -5. Okay, so remember the process. You bring down the 1, multiply back by 2, subtract those, multiply back by 2, subtract that, multiply back, and we get 0. Right? Remainder should be 0 if we're dividing by a factor. We already know that x plus 2 is a factor of a polynomial, then the remainder should be 0. And it is. Okay, so the remainder is 0. Let's check it out by substituting the value of x that makes this 0, which is -2. And it should be 0 as well. Okay, so okay, so both of them are 0, either way. Really, you'll end up using, when we are factoring these higher degree polynomials, you might end up using synthetic division more, because you do get it broken down into smaller parts. Okay, but this is a fast way of checking if something's a factor. And we're not always going to know what it is a factor. So it says write your results from part A in the form. So P of x is equal, I'm not going to copy out P of x. Now I'm going to write it in this form. So the divisor is x plus 2. The quotient, remember, is x squared minus 4x plus 3. This is x squared minus 4x plus 3 plus 0. So really, we don't have to show that. Okay. So we have now, if you look at this, we've now taken that polynomial function, or even if it's just an expression, you don't have to call it anything, and we've now factored it. Okay. So if we didn't have the graph to come up with those x-intercepts, you might have been a little bit stumped as to how to get a cubic into factored form. Okay. Yeah, you have your calculator, but you need to be able to do this even without a calculator. So that's the goal. Find a factor of the polynomial, divide it, and there you've got it in factored form. Okay. Now you can factor that fully, and we're going to continue in a minute here. Here's our conclusion, though. If P of x is shown in this form, divisor times quotient plus remainder, and the remainder is 0, we've now factored our polynomial. Okay. Now it says here that d of x is always in the form x minus a. We are going to have some that have a coefficient here, particularly for IB courses. So you can change that a little bit. Bx minus a or ax minus b, right? Doesn't really matter. But the fact is, you will have some that have a coefficient. Okay. All right, so then it says determine the remainder when P of x, same P of x as above, is divided by its other factors using the remainder theorem. So not synthetic, but our other factors were, we take a look, x minus 1 and x minus 3. So for factor x minus 1, that means we're going to substitute positive 1 in. For factor, what did I just say, x plus 3, x minus 3. Then we substitute positive 3 in. Okay, so do that, check. Make sure you get a value of 0. Okay, 1 minus 2 minus 5 plus 6 is 0. And then here, that's going to be 3 cubed minus 2 times 3 squared. Slow. Minus 5 times 3 plus 6. So 2733 minus 3, so that's 0. Okay, and that's what it should be, right? So if you substitute a number into a polynomial and you get 0, that means a factor of that polynomial is x minus this number that you substituted in. Okay, so p of 2, what happens there? So if I substitute p of 2 in, okay, I get 8 minus 8 minus 10 plus 6. So in this case, I get negative 4. So that means, so therefore, x minus 2 is not a factor of p of x. Now, what's interesting, I want you to take a look. We copied the graph out here. So this is the graph of p of x. If I take a look at this and look at the point where x equals 2, okay, what's the y value there? It's negative 4, right? So from the graph, your y value tells you your remainder when you divide by x minus whatever x value of that point is. So here, when x is 1, I have a y value of 0. That means the remainder when dividing by x minus 1 is 0. That means x minus 1 is a factor. X plus 2 is a factor. X minus 3 is a factor. Any other values, so x minus any of the other values, are not factors, and the remainder is whatever the y value is. Okay, so that point is 2, negative 4. So when we substitute 2 in, we get negative 4. That means x minus 2 is not a factor. It also means the remainder when dividing by x minus 2 is going to be negative 4. And the computer's a little slow, but I think it'll catch up there. Okay. All right. Look over. To summarize here, so the binomial x minus a is a factor of a polynomial function if and only if, so remember that's a biconditional statement, if and only if a is a 0 of the polynomial function. So that means it's an x-intercept of the graph. In other words, x minus a is a factor of a polynomial function f of x if and only if f of a equals 0. All right, so these are just different ways of saying it, forwards and backwards. So if we know that f of a equals 0, that means a, 0, that point is the coordinates of the x-intercept. Okay, or you can say a is the 0 of the function. It also means that when you're dividing f of x by x minus a, the remainder is 0. So it is a factor. So it says here, in this course, you'll be only asked to factor polynomials where the coefficients are all integers. Yep. These types of polynomial functions are called integral polynomial functions. So that's not to be confused with integrals that you will take in calculus. That's something different. In this case, is an adjective to describe the polynomial function. It's made up of integer coefficients. Okay, so let's look at some examples here. So here we're given another polynomial function. If you take a look at that and you want to maybe factor it, no idea how, right? You can't factor by grouping, and this is degree 3, 4 terms. So we need to do some work. So we're going to prompt you here. So Sam needs to show that x minus 3 is a factor of p of x. He can do this by showing that the remainder, oh gosh, that the remainder, all right, now going through the whole process here. Okay, that the remainder is equal to 0 when p of x is divided by x minus 3. One way to do this is use synthetic or long division. Do it. Okay, I would probably use synthetic. Okay, so you're going to be really good with synthetic. Okay, so we can see that the remainder is 0. Another way is to substitute 3 into p of x and show that p of 3 equals 0. So now do that. I guess this is lowercase p. Calculator if you want. 3 cubed minus 2 times 3 squared minus 23 times 3. Oh gosh. Sorry. Get out of the exponent. Oh, plus 60, and I did 6, so plus 54. 0. Okay, so now that you know that x minus 3 is a factor of p of x, completely factor it. So we go back up to the synthetic division. So p of x is equal to x minus 3, and then from here, we know that this represents x squared plus x minus 20. So x squared plus x minus 20. And now you can factor that trinomial. It's factorable. Sometimes it won't be, but this one is. So back to math 10, factor that trinomial. Okay, so now you've got it in factored form. So part C says, if you're required to factor p of x, is it better to determine that x minus 3 is a factor? This means finding the remainder of 0 using synthetic division or the remainder theorem. Well, this was really ended up being kind of a little bit of a waste of time. You already knew that the remainder was 0 above it. Okay, so, and that, using synthetic, you've got the second factor. Okay, so in this case, I would use synthetic. And basically, we'll see as we go on in this unit, because you have a graphing calculator, you're going to be able to figure out what factor to even start with, because you can look at a graph. When I was in high school, we didn't have graphing calculators. And sometimes we weren't even allowed a calculator. So what we had to do is we had to test numbers, and there's a strategy, we're going to learn that in a second. Test numbers and substitute them in until we got one that gave us 0. Okay, then we knew we had a factor. But we didn't have a calculator, we didn't have a graphing calculator. So we had to do that and then use our synthetic or long division. Okay. So it is a little bit easier to use this synthetic division first, then you don't have to do it twice. Yeah? Yeah, that's what I said. You still have to show your work. In calculus, you won't have a calculator, so you're going to have to do this in calculus. So we're allowed to use it now, and you're in Math 20 and in Math 30, but you're going to have to be able to do this without a calculator. So we're learning the steps, showing the work, but you have that backup of a calculator. Yeah, but yes, you will. Yeah, but you're still going to have to use synthetic no matter what, or long division, right? So you can choose between those. Synthetic's a little bit faster. Okay. So taking a look at this one, it says show that 6 is a 0 of that polynomial g of x, and express the equation of the function in factored form. So if it just said show that 6 is a 0, I wouldn't use synthetic. I would just substitute it in. But it says express the equation of the function in factored form. So I do have to divide and get what the remaining factor is. So I'm just going to use synthetic to begin with. So that means if this is a 0, then x minus 6 is a factor. Or we're going to show that it is. So x minus 6 into our polynomial. Okay, so remainder 0. So we can say, I guess here I should say is x minus 6 a factor. So that's what we're wondering. So then we divide the polynomial by x minus 6. We get a remainder of 0. So then you can say since remainder equals 0, then x minus 6 is a factor. Okay, so now we will need to factor it, so it's called g of x. We know x minus 6 is one of the factors. Now here, the remaining is 2x squared plus 5x minus 3. Okay, and check that out. Can we factor that again? Are there two numbers that multiply to negative 6 and add to 5? So that would be multiply to negative 6, so we could use 6 and negative 1. Oh no, I have a negative there for some reason. Sorry, it's positive. So that's a positive there. So multiply to positive 6 and 5. So that, there's no way. Too bad it wasn't negative. We could factor. That one can, so we're done. Sometimes that's as far as you can go. Okay? So 2x squared plus 5x plus 3. I had put a minus there to start, so make sure you have a plus. Yeah? Oh, sorry, 6, multiply to 6. Oh yeah, we can. Good. Sorry. So I was thinking the other factors. So this would be 2x, and that would be plus 1 and plus, no. Yeah, sorry. There you go. Okay, so if you just were asked, is it a factor, you can just substitute 6 in. If you're asked to actually factor it, you might as well use synthetic. And then if you can factor again, go for it. Sometimes you can't. Right? So this one is pretty similar to one that we did yesterday, except the one that we did yesterday gave us the remainder, and this says they are both factors. That means the remainder is 0. Okay? So it's very similar to yesterday's. So this is a polynomial expression. If x minus 1 is a factor, that means that when we substitute x equals 1, okay, so when x equals 1, the remainder should be 0. So the value of that expression should be 0. Notice how it's not called anything. It's not called p of x. If you want to name it, you can. Or you can just show that when you substitute 1 cubed minus a times 1 squared plus b times 1 plus 8, that's equal to 0. Okay, that's what we know has to be true. So simplify both of those equations, and then you're going to have to solve a system. Okay, and then, so that's that one. This one is negative 8. Minus 4a is 2b plus 8. Okay, and that I could divide both by negative 2. Okay, you decide what method, substitution or elimination. I'm going to use elimination. So the b's go away. So a equals 3. And so b equals negative 6. Okay. So we found the values of a and b. So it's always a good idea. It didn't say to state the equation or the expression again, but I like to, I'm going to go over here because I ran out of space. Just rewrite it with those values substituted. So notice how it's minus a there. So it's going to be minus 3. Because our a is 3, so we're subtracting 3x squared. And then b is a negative. We're adding the negative, so it's minus 6x plus 8. So that's our polynomial expression. Okay, so we basically know the process now of how to factor a polynomial expression. If we've been told one of the factors, or if we maybe use our calculator to get one of them. But we have to, as I mentioned before, go through the process, kind of pretending we don't have a graphing calculator, but we're going to use it. So we're going to back up our work on our paper, but have our calculator to help us get there faster, okay? So leading up to that, basically what we want to do is figure out a way to know how to test or what values to test in the polynomial, right? Rather than just going through when x equals 1, 2, 3, 4, etc. Okay? You don't want to have to do that. So what are some properties of a polynomial? So that's what we're going to look at right now. So if you're asked to factor this p of x, how would you start? One way would be to find an x-intercept of the graph. Obviously, and that's the easiest way, using your calculator. Once you find an x-intercept, then you would conclude that x minus k is a factor. You could then use synthetic division to determine the other factors. So how would we do this algebraically without a calculator? So we're told the zeros of the polynomial function p of x are -3, -1, and 2. Write an equation. So notice how it says an equation, because there could be stretch factors, but an equation has to have those factors in it. So x plus 3, x plus 1, x minus 2. Okay? If you multiply it by something, it still has those same x-intercepts. Okay? What does that look like in simplified form? Well, okay, so this is going to take, we're not going to do this every time, we're just showing the process. So we need to expand these out. So I'm going to choose the second two, or the last two binomials and expand those. So x squared minus 2x plus x is minus x minus 2. Okay, then expand that out. X cubed minus x squared minus 2x plus 3x squared minus 3x minus 6. This is just rough work on the side. So p of x then is x cubed plus 2x squared minus 5x minus 6. Notice the constant term, okay? What is it? It's -6. Well, how did we get that constant term? We had to, in the two binomials here, we got -2, so we multiplied those two constant terms in these two binomials to get -2, and then we multiplied that by the 3 in the first factor. So basically, that constant term is the product of all the constant terms in the factors. Okay? So when the constant term of p of x is divided by each of its zeros, -3, -1, and 2, the remainder is. So take a look at it. All of these numbers go into it evenly. So the remainder is 0. Okay? So that means each of the zeros of p of x is a factor of the constant term. Now, this is not a biconditional statement. Every factor of the constant term is not going to give you a factor of the polynomial, right? So -1, 2, and -3 work, but +3, +1, -2, 6, and -6 don't work, right? But what we know is that it narrows it down, that the potential zeros are factors of the constant term. So based on this, another factor of the constant term of p of x, well, that's going to be divided by each of the zeros, is going to be -3. All right, here. So negative, another factor of the constant term of p of x would be negative 3. Okay. Oh, I see. Yeah. So this is what I was just, sorry, I reread this. I read this incorrectly. So another factor, let's say positive 3. Okay, that's what I was just saying. If I check this in p of x, if I substitute 3 in, I would get 3 cubed plus 2 times 3 squared. You don't have to do this. I'm just showing it to you. And that is not equal to 0. Okay? So that's a factor of the constant, but it is not going to give you a factor of the polynomial. So just like I said before, every factor of the constant term is not going to give it to you, but some of them will, right? So it narrows down your choices. So that's the summary here. If an integer a is a 0 of a polynomial function, then a is a factor of the constant term. And as I've said now 3 times, the converse is not true. If a is a factor of the constant term, it is not necessarily true that a is a 0 of the polynomial function. Okay. So let's practice a little bit of this. This f of x here now, it's a degree 4. The leading coefficient is 1. Constant term is negative 8. Okay, so on a test, I can almost guarantee that we'll have a question like this, either factoring or maybe solving, and it will be doing this algebraically. Yes, you have your calculator to help you, but we're going to do it algebraically. So first thing is to state what we call our potential zeros. So that's where we look at the factors of negative 8. And what are the possible factors of negative 8? So positive 1 and negative 8, or negative 1 and positive 8. So we just put a plus or minus in front of both of them. Then 2 and 4. Okay. Nothing else though, right? 3 doesn't go in, 5 doesn't go in, you're done. All right. So back in the day when I was young, this is where I would then do it by hand. Maybe we're allowed a basic calculator, but I would substitute each of those values in for x in f and see when I get 0. You don't have to do that. You do have a calculator, but this will need to be recorded on your paper for a full algebraic solution. So go to your y equals, and yeah, you could substitute them in using your calculator, but what if they don't work? Might as well use the function, and then you can test more than one. Okay, so I'm going to use the standard screen, because all of those values fall between negative 10 and positive 10. Okay, so looking at it, I see it looks like it passes through right through negative 1. So if I test that, rather than even doing the 0 feature, I get 0. So that saves me a few steps in my calculator. So I can say here, try x equals negative 1, and then you can just say f of negative 1 equals 0. That's kind of what you're doing in your calculator. So some teachers are kind of picky that they actually make you put it into the factor theorem, but I'm not so much, as long as you write something else. Guys, can you put your phones away? We're almost done. Okay, so that means that x plus 1 is a factor. Yes, we could come up with the equation just by looking at our graph in our calculator, but we're showing the algebraic work. Okay, so we're going to do our synthetic division. We may actually have to do it twice because it's degree 4, but we'll see. Depends if we can factor. If you don't get a zero remainder here, then you did something wrong if you think that it should have a zero remainder. So it's kind of a check for you. So now I'm going to write out, okay, well, f of x has a factor of x plus 1. I'm going to write out the other factor. So remember, it was x to the fourth to start, so this would be x cubed minus 6x squared plus 12x minus 8. Okay. I don't know how to factor that, right? So I'm going to have to do the same process again. Now, in our calculator, we can still use some of those potential zeros, right? They still have to be part of it. It still comes from that. So now I can try another factor. And again, if I look here, it looks through like it zigzags through 1, right? So that means it should factor to, oh, sorry, not 1, 2. It should factor to x minus 2 cubed if it's got that point of inflection. But let's, again, we have to do this algebraically. So, so we would try x equals 2 and f of 2 equals 0. Therefore, x minus 2 is a factor. Now, I'm not going to divide the original by x minus 2. That's not going to help me. I'm going to divide this by x minus 2. Trying to get it factored out. Okay, so -4, that's an 8. Okay, so now f of x, we go back, we need to include the x plus 1, we include the x minus 2, then we include the quotient here, x squared minus 4x plus 4. And that can factor again. All right, and that factors, that's a perfect square trinomial. So that factors to, let me go do that just in red here. I'm running out of space. That factors to x minus 2 squared. Right, and I already have an x minus 2. So my final will be f of x equals x plus 1 times x minus 2 cubed. Okay? Now, if you show 3 factors of x minus 2, that's not wrong. But we like to combine them, right? Use your powers. Now, it says sketch the graph. Well, you have it, your calculator. You have it in there. So it's not really a big deal to sketch it. We know we have to have a point at 2, and then a point at -1. Okay, positive leading coefficient means it goes up and to the right. It's degree 4, so it's going to go up and to the left. And remember, multiplicity of 3 means it zigzags through there. So really it's going to go like this, and like that. Kind of missed the point, but I'll, oh. What the heck? Oh, sorry, more practice. 4, 5, 6, 7, okay. Okay, so sketch the graph, labeling the intercepts. We can find the x-intercept. Just look at the expanded form of the equation. It was -8, right? So that's going to be -8 there. And then state the domain and range. Well, the domain will be all real numbers because it's a polynomial function. The range, you're going to actually need to use your calculator for this one. When you get to calculus, you'll be able to figure it out. But right now we can't. So on your calculator, find the minimum value. So actually, it goes through, I can fix that a little bit. Let me just fix this up a little bit. Minimum's going to be a little bit below there. There's -8. And then my minimum point. Second trace minimum. Cursor close to the lowest. Enter. Right, enter, enter. And the y value there, -8.54. Come on. And that's, okay, so that gives you some good practice.